Good morning, all of you. Now I am going to teach you about instrumentation subject. Under this instrumentation subject, the first unit is characteristics of signals and their representation. And the syllabus under this first unit is measuring instruments, performance characteristics. Under performance characteristics, we will be having static characteristics and dynamic characteristics. And errors in measurement, what are the different errors in measurements? Those are gross errors, systematic errors, random errors. So, and statistical analysis of random errors, signals and their representation. Under the signals, standard test, periodic signals, modulated signals, all will be there. And sample data, pulse modulation, and pulse code modulation. So, these are covered under the first unit. Coming to the definition of instrumentation, what is instrumentation? Before going that, first, what is measurement? That means if you want to measure current, you will be using an ammeter. So to measure a current, you will be using the ammeter. So what are the different types of ammeters? What are the different types of voltmeters? So those are nothing but the instruments. Under instruments, now we can go to the definition as instrumentation is a collective term for instrument, measuring instruments that are used for indicating, measuring, and recording physical quantities. So these are nothing but the instrumentation is the subject which deals with the instruments, which are used for measuring the physical quantities. So this is about the instrumentation. So instrument is required to measure unknown quantity or value or variable. So anything which is unknown quantity or a value or a variable can be measured using an instrument. So this instrument can be it is nothing but a measuring system. So this measuring system can be explained using this block diagram. So this is the block diagram of the measuring system. So under that, first we need to know which quantity is to be measured. The quantity which is to be measured, it is given to the primary sensing unit. So this primary sensing unit can be a transducer. That can be a transducer. That means whatever the quantity is to be measured, it is given to the primary sensing unit. So that primary sensing unit, it will first sense this quantity and then it will convert the uh, quantity into the required signal. So that is nothing but the variable conservation element. So after that variable converting that element, it is given to the variable manipulation element. So that variable is manipulated, and if you want to store that data, it can be given to that data storage. And if you want to use that data and transmit somewhere, it is given to the data transmitting element. And from the data transmitting element, it is given to the data presentation element. So this data presentation element is nothing but the output screen where you will be seeing the output so that the output can be observed by the observer. Okay. Again, this variable conversion element and the variable manipulation element are called as data conditional element. These two are also called as the data conditional. So conversion plus manipulation is nothing but the condition. So this is the block diagram of the measuring system. So we can explain this block diagram for the measurement of current using MC ammeter. So in the labs we have used the MC ammeters. Those the ammeters which are used for measuring DC current are nothing but the MC ammeters, and for AC you will be using the MI ammeters. So suppose now we are considering the MC ammeter. So for that you will be the physical quantity here is nothing but the current. So that current is given to the moving coil. So this moving coil will be moving under the magnets, And magnet and any parameter are nothing but the data conditioning elements here. And the mechanical linkages like the springs and all the pointers, all are the mechanical linkages. So that the pointer will be moved over the scale which is given on the top of the meter. So this is nothing but the presentation element. So if you want to print the data also, you can connect a printer here so that you can print the data, and this can be observed by the observer. Okay, this is the measurement of current using MC ammeter. Coming to the performance characteristics, so the different performance characteristics here are, there are two types of performance characteristics. Those are static characteristics and dynamic characteristics. So by the name itself we can know static means which does not vary with respect to time. So the characteristics which does not vary with respect to time are called static characteristics, and the parameters which vary with respect to time are called the dynamic characteristics. Under the static characteristics, there are several static characteristics are there. Those are accuracy, precision, linearity, dead zone, sensitivity, resolution, hysteresis, stability, range or span, drift, error, threshold. So all these are nothing but the static characteristics. We can explain one by one now. Accuracy. So what is the meaning of accuracy? So whenever you are measuring a quantity, how accurate the instrument is, you will be checking, right? So in that, the accuracy, it means it indicates the degree of closeness of the measured quantity with respect to time. So how much reading is close to the real value, true value, that is nothing but the closeness of the measured quantity. So this is nothing but accuracy. So this can be explained by an example here. So suppose the true value of a current at 2 ohms resistor is 5 amperes. Suppose in a 2 ohms resistor, the true value of current is 5 amperes. And if you are using two instruments, in that instrument A is measuring it is showing 4 amperes, and instrument B is showing 4.5 amperes. Suppose in a circuit, if you calculate theoretically, the value is current in the 2 ohms resistor is 5 ohms we are giving. While measuring that current by using an instrument A, you are getting 4 amperes, and by using instrument B, you are getting 4.5 amperes. So in these two, which instrument is close to the 5 amperes? That is nothing but instrument B. So that means this instrument is more accurate than the instrument A. So hence B is more accurate than instrument A. Precision. So precision means it is nothing but the most reproducible value out of a set of records is called precision. So this is the most reproducible, and that means how many times this is going to reproduce the same value. So if you suppose if you consider 10 times, so in that 10 times, how many times the value is more repeatedly got? That is nothing but the precision. Suppose see here, the true value of an ammeter is 20 amperes. If you measure it with A, then you are getting A for you are taking 5 observations. So out of these 5 observations, you got 15 as 2 times and 19 as 3 times. And for B, with B instruments, if you check 5 times, in those 5 times you are getting 3 as 15 and 2 as 19. That means here the most repeated value is 15. Most repeated value is 15. That means and 19 is not repeated many times. Here, whereas here 19 is more repeated, and 19 is very close to the 20 also. That means it is more accurate and precise. Whereas for B, it is only precise. That means many times it has repeated 15, but it is not close to the 20. So that means it is only precise and not accurate. Next, linearity. Linearity means if the output follows the input with linear equation, then it is called to be in linearity. So that output, the graph between the input and output is linear, then it is said to be obeying linearity. Suppose take for example for MC instruments, theta is proportional to I. That it means it is linear. The angle is directly proportional to the current, then it is said to be linear. For unmade instruments, theta is proportional to I square. That is, it is not linear. It is non-linear. Dead time. So dead time is the time taken by the instrument to move the pointer from initial position is called dead time. So that means it is taking too much of time to move the pointer. Initially, whenever you switch on the supply, some meters take some time to respond. So that time, how much time it is taking to respond, that for the till that time it is under the dead position. So that time is called the dead time. So we cannot avoid this dead time, but we can reduce by using the lightweight pointers. So if you are using lightweight pointers, then this dead time can be reduced. Dead zone. This dead zone is also called as threshold. So under threshold is nothing but dead zone is the minimum input beyond which the response will come. So you are providing some input and you are getting output only after some value of input. So the minimum amount of input after which you are getting the output, that is called nothing but dead zone. That is called dead zone or threshold. Suppose see here, by considering this graph, we can say this is the input and this is the output. See here, you are not getting any output. So this is called the threshold value. But after this value, you are getting some output. So this is so the dead zone or threshold value is nothing but from here to here. So suppose from 0.7 you are getting the output. So 0.7 is nothing but the threshold value of that instrument. Sensitivity. Sensitivity means it is the ratio of change in input to the unit change in input. So change in output to the unit change in input. So if you for some amount of input change, then you are getting some amount of output change. So how much ratio you are getting? So it is the ratio of change in output to the change in input is called the sensitivity. Resolution. So a resolution is nothing but the smallest change in input that we can identify on the scale with clarity. So there is a scale, you will be having a 10 on that minimum amount of point you can observe is 0.1. Right? So that 0.1 is the resolution of that instrument. So it is nothing but the smallest change in input that we can identify on the scale with clarity is called the resolution. Coming to the dynamic characteristics are governed by the following factors: speed of response, fidelity, lag, dynamic error. Speed of response is nothing but the how much time. Dynamic characteristics means these are depending upon the time. These are depending upon the time. These vary with respect to time. So how much speed, how much fast you are observing the response. It is nothing but the speed of response. Fidelity means it is nothing but the how much sensitivity. It is how much sensitive, how for a time, how it is going to react. It is nothing but the fidelity. And lag is nothing but the how much it is lagging with respect to time. That means it is very too late for the response. That is nothing but the lag. And dynamic error. Dynamic error means it is you will not be knowing that error. It will be you will be observing the error with respect to time. These are called the dynamic characteristics. So error is nothing but it is the deviation of measured quantity with true quantity is called the error. So error is equal to measured value minus true value. So these are the different characteristics. So there are you have observed There are two types of characteristics. Those are static characteristics and dynamic characteristics. Under static characteristics, we have observed all these things. Um, and under the dynamic characteristics, you have observed the speed of a response, lag, fidelity, and dynamic error. Okay, these are the different characteristics of an instrument. So these are the performance characteristics. Okay, thank you.